Hello all. In this discussion, we will look into the next experiment of our lab. That is the third experiment, design and implement MLP model to classify 32 by 32 images using TensorFlow and check the accuracy. The dataset what we are using here is CIFAR10 dataset, which has total of 60,000 images of size 32 by 32, and all are colored images in belonging to 10 different categories. Out of 60,000, 6,000 belong to each category. So as I have 10 categories here, we will have 60,000 images. All these are the 10 categories you can see. So the first step here is importing of all the libraries. So I'll be importing the sequential model. I'll import dense layer, that is fully connected layer, flatten layer to flatten the convert multidimensional to single dimension. I'll import this CIFAR10 dataset and import to categorical to convert categorical to numerical values, and then load the dataset. This is the dataset what I have loaded. Next is the visual representation of the dataset. You can have here a few images of the dataset belonging to 10 different categories. Next step is I'll normalize the data by scaling the pixel values within the range 0 and 1. And then one-hot encoding, I'll convert all the class vectors to binary class matrices. The next is building the MLP model. So first I'll create an empty model, sequential model, where all the layers which are being imported will be placed one after the other. And the first layer which is passed is flattening, where the multi-class images are converted into one-dimensional. Next is the first hidden layer with 512 neurons ReLU activation function. Second hidden layer, you can have as many hidden layers, but to reduce the complexity I have used here only 2 hidden layers, and the output layer with 10 neurons, as we have 10 different classes, and obviously the activation function will be softmax function. Coming to the model summary, which will print the entire summary of the model what we have created. These are the flattening layer, 2 dense layers, that is 2 hidden layers, and this is the output layer. So total of these many trainable parameters in my model. Next I'll compile the model. I'll compile the model using the optimizer. What I have used here is Adam, which will be used for adjusting the weights during training. Next is the loss function, which is categorical cross entropy, because this is multi-class classification. If it is binary, we will use binary cross entropy, and the metrics which is used here to measure the performance during training is accuracy. Next I'll train the model with 10 epochs and batch size as 32 and the validation split as 0.2. So I have used this batch size as 32 because 32 samples will be processed before updating the model's weight, and the validation split is 0.2, that is 20% of the training data will be used for validation to evaluate the model's performance on the unseen data after every epoch. So you can see here the output what I get is all the 10 epochs output will be generated, which has training accuracy, training loss, this one, validation accuracy and validation loss. And you can see here 1250 by 1250, which represents the number of batches which are being processed per every epoch. And why it is 1250? Because the batch size what we have used is 32 and the number of training samples we are using is 40,000. Out of 60,000 we are using training samples as 40. So the number of training samples 40 divided by the batch size 32 will be 1250. So depending upon this batch size and the training samples, we will get these number of batches which are being processed. So I will get accuracy, training loss, validation accuracy and validation loss for all the 10 epochs. Just have a quick idea of categorical cross entropy. It is also known as softmax function, and this is the formula to calculate cross entropy, which belongs to multi-class classification. Next, we will evaluate the model and calculate the accuracy of the unseen data, how the model is performing. So we can see that the accuracy what we have got is around 48. percent. Next, we will train the model. We will plot the training and validation accuracy. And this is the plot what you get here. Blue colored graph represents the training accuracy and orange color graph represents the validation accuracy. And what you notice here is the accuracy of the this is the blue colored line, which is the training accuracy. It is gradually increasing, which indicates that the model is learning from the training data. And validation accuracy will be generally flowing. It is also increasing, but what you notice is it is getting flattened after the 5th epoch and then increasing again. So around 6th and 7th epoch, the validation accuracy is getting flattened, while the training accuracy is continuously improving. So we can just suggest that the model might be starting to overfit here after 6th epoch. But there is not a lot of gap between this training and validation accuracy. If there is a lot of gap, then we can go for early stopping or dropout layers or data augmentation, as well as increase the number of epochs as well. Now, as per this graph, we can say that our model is not overfit because the validation accuracy is close to the training accuracy.